Welcome everybody. Now we are going to see one IC. Name of that IC is 7490. So what is 7490? So this is block diagram of 7490. So let's see. 7490 is ripple counter IC. So 7490 is counter IC, means it can be used for some counting purpose. We have seen that in counter there are two types. First one is asynchronous and second one is synchronous. So 7490 is asynchronous. Okay, 7490 is ripple counter. Now 7490 is decade counter, that is mod 10 counter. So what is meaning of decade counter? Decade counter means 7490 can count from 0 to 9. Okay, so 0 to 9, how many states? 10 states. So I can say that in 7490 we will have how many states? How many different states? 10 states. So that's why 7490 is also called as mod 10 counter. It consists of 4 flip-flop internally connected together. Now we have seen that if we have 2 flip-flop, then by using 2 flip-flop, how many states are possible? 4 states, 2 raised to 2. If we have 3 flip-flop, how many states are possible? 8 states are possible. Here we want mod 10 counter. So in order to design mod 10 counter, whether 3 flip-flops will be sufficient? No, we will require 4 flip-flop. So that's why in 7490 internally there will be 4 flip-flops which are connected together. So 7490 contain 2 separate counter. One is mod 2 and second one is mod 5. So see this block diagram. So in this block diagram you can see this first box. So this first box is labeled as flip-flop A. So this flip-flop A present in 7490 forms mod 2 counter. Right? So in order to design mod 2 counter, how many flip-flops will be required? So mod 2 means it will have 2 states, either 0 or 1. So in order to design mod 2 counter, we will require only 1 flip-flop. Okay. So see this particular box, it corresponds to mod 2 counter. It is going to act as mod 2 counter. So what is input to the counter? Clock pulse. Okay. So see here you can see one input A, right? So this is input with the help of which you can provide clock that is required for this mod 2 counter, right? Now mod 2 counter will have one output. So see that output is labeled as QA. So this is one counter which is present in 7490. Now in 7490 there is one more counter and it is mod 5. So mod 5 means it will have how many states? 5 states, 0 to 4. So in order to design mod 5 counter, how many flip-flops will be required? Whether one flip-flop is sufficient? No. Whether 2 flip-flops are sufficient? By using 2 flip-flops we can get 4 states. Here we want mod 5 means here we will require 3 flip-flop, right? So in order to design mod 5 counter we will require 3 flip-flops. So see here this second box which is present in this block diagram, it corresponds to mod 5 counter. So in order to design this mod 5 counter internally, how many flip-flops has been used? 3 flip-flops and some gates. So we are not interested in internal architecture of this mod 5 counter. Okay, so just try to understand block diagram of 7490. So 7490 internally has these 2 separate counter. First one is mod 2, okay, and second one is mod 5. So input to mod 2 is this input A. By using this input you can provide clock pulse which is required for this mod 2 counter, and this mod 2 counter has one output, that is QA. Similarly, this is mod 5 counter. So what is input to counter? Clock pulse. What counter counts? Clock pulse. So this mod 5 counter will also require some input through which we can provide clock pulse to that counter. So see here we have one input. It is labeled as input B. So by using this input B you can provide the clock pulse which is required for mod 5 counter. Now mod 5 counter will have how many outputs? 2 outputs or 3 outputs? By using 2 output we can represent only 4 states. Here we have 5 states, so here we will require 3 outputs, and those outputs are labeled as QB, QC, QD. Okay, so I hope now it is clear to you that 7490 contain 2 separate counter, mod 2 and mod 5. So this counter can be used as independently or in combination to provide mod 10 counter. So if you want to use these 2 counters separately, okay, suppose I don't want to use this mod 5, I don't want to use only mod 2, it is possible. Now suppose I don't want to use mod 2, I want to use only mod 5, it is possible. And even you can combine these 2 counter, you can cascade this 2 counter. Okay, so if we cascade this 2 counter, then it is going to act as mod 10 counter. So here try to understand that if we have mod m counter, okay, and second one is suppose mod n counter, right? First counter is mod m, so mod m means it will have m number of states. Second counter is mod n, means it will have n number of states. So if we cascade these two counters, so how this cascading can be done, that we are going to see. So if we cascade these two counter, then resulting counter will be mod m into n. Okay, so if we cascade these two counter, one is mod m and second one is mod n. So after cascading these two counter, we will get a counter which will have how many states? M into n. Resultant counter can be considered as mod m into n counter. So here if we see this example, so this is mod 2 and this is mod 5. So if we combine them, then resultant counter will be 2 into 5, that is mod 10, right? Then there are two reset inputs, R01 and R02, both of which are to be connected to logic 1 for clearing outputs of counter. So in this block diagram you can see two pins, one is labeled as R01, okay, and second one is labeled as R02. So what is use of this two pin? So if these two pins are connected to logic 1, if these two pins are connected to logic 1, what is going to happen? Outputs of counter will be cleared. Okay, so if you want that outputs of this counter, so which are output of this counter? QA, QB, QC and QD. So if you want to reset all these outputs, okay, if you want that output of this counter, it should be 0 0 0 0. What you have to do? Simply you should connect this two input pin of 7490 to logic 1. So I can say that these two pins are active high pin. Okay, we have seen that some pins are active low. So active low means there if we apply logic 0, then those pins will be activated. Now here these two pins are active high, means here we have to apply logic 1. So if we apply logic 1, then these two pins will be activated. When these two pins are activated, what is going to happen? Output of counter will become 0. Okay, so here you can read this input as reset to 0. R stands for suppose reset. So reset to 0. So when this two pin becomes active, then counter will reset to 0. Now in this 7490 you will find two more reset input. One is R91 and second one is R92. Okay, we have these two input pin R91 and R92. So how to read R9? R9 means reset to 9. R0 means reset to 0. Okay, so if you want to reset this counter to 9, okay, so if I reset this counter to 9, then what will be the output? So 9 means most significant bit will be 1, then next bit will be 0, next bit will be 0 and next bit will be 1. Okay, so this is binary 9. If I convert it into decimal, I will get 9. So if you want that this particular counter, output of this particular counter should reset to 1001, then what you can do? You can make use of this two pin. What you have to do? Simply you have to set these two pins to logic 1. Simply you have to connect these two pins to logic 1. So if I apply logic 1 to these pins, what is going to happen? Output of counter will reset to 9. And if you don't want to use this reset pin, then this reset pin, they should be connected to logic 0. Please try to understand. These pins are active high pin.